Okay, so we are going to be biasing a transistor, which is simple, I know, but we're going to be doing it to make a H-bridge inverter, which will convert DC to AC power. Why are we doing this? I have no idea, but it needs to be done, so let's get to it. First thing that we do is this is a PNP transistor. Okay, very small. It's like the most common transistor you can find. Literally any PNP. You're gonna need two types. You're gonna need NPN and you're gonna need PNP. So keep that in mind. I'll show you once I have this installed, and I'm gonna label what pins are what. Okay, so we're back. And I don't know if you can see that or if that's reversed, but this is the pin out again, very, very simple. And then we have the transistor right here. You can see that, if that's going to focus. So obviously the middle pin is going to be the base. We're going to have this as the emitter, and this is a collector. For a PNP, the roles are reversed. So what you're going to realize is that an NPN, the emitter is where it goes to ground, and the collector is comes from a positive source, but the PNP is different. So the source goes into the emitter, and then ground goes out of the collector. So let's wire the base up. Let's get an LED on this thing, and I'm going to show you how this works. All right, so we have it all hooked up, and I'm about to show you right now that it's all hooked up. So again, this is a PNP transistor. I might just have to flip this around. Okay, so we have the Arduino hooked up right here just to 9 volts. We have V in and ground hooked up to the 2 power rails. Now again, this is a PNP transistor. So we have positive voltage going into the emitter, right? Now where that goes into is it goes into the collector, which is hooked up to the positive side of the LED, comes out the negative side, goes into a resistor. This resistor is so important because if you don't have it, you're going to burn out your LED. Your LED will absorb too much current and will burn out. From here, it goes back to... That's really weird. Oh. Sorry. My bad. I think we've created an error here, but this resistor goes straight... What? How the hell did that even work? I am so sorry. We were so lucky. Alright, let me fix this right now. The problem right here is that this resistor isn't connected to ground. It's connected to this resistor, which is connected to the gate. That's the problem. Let's fix that and I'm going to show you. Okay, we're back. I fixed it. So as you can see, we'll run through it one more time. We go into the emitter, and then it comes straight out of the collector into the positive side of the LED. LED comes into a resistor, as I've said, because if we don't have the resistor here, it will just burn out and run out. That goes into ground, right? Now our gate is connected to our source voltage because in order to turn this transistor off, we put the source voltage into the gate, right? That's connected to a resistor just to control the current going into the gate, and that's also connected to ground. Now watch when we disconnect the base, so that will drop below 0, LED turns on. If we connect it back in, LED turns off. On, off, on, off, on, off. And that is how you forward bias a PNP transistor. I could go into depth about how we bias it, but just a rule of thumb for a PNP transistor, in order to turn it on, you're base voltage needs to be lower than your emitter voltage, right? So your emitter voltage needs to be higher than your base in order to turn it on. And to turn it off, your base voltage needs to be higher than your emitter voltage to turn it off, okay? Even though they say they're current controlled, which blows my mind, but anyway, that's why we're here to learn. So I will see you when we have 2 transistors in a row, and it will be a PNP and an NPN.